In this video, we are going to study sources of energy, and this is a very short chapter, and we will be covering it in 10 to 15 minutes only. So now let's discuss about the good source of energy. What is a good source of energy? So the good source of energy can be defined as like which would be which would do large amount of work per unit. So it should be efficient, and it also should be accessible. It should be easily accessible and can easily be stored and transported, and also most importantly is the be economical. So all these criteria uh, is needed to fulfill the good source of energy. It should be producing high amount of work per unit volume, large amount of work, which is efficiency of this, and it should be the source of energy should be accessible and can be stored and transported easily, and be also be economical. It is very cheap. So how we get the energy from, and what are the sources of energy? Let's talk about it. First, there are conventional sources, and in which we will study fossil fuels. Let's look at the chart first. And this chart shows that coal is the major forms of energy. We take almost like more than 50% of our energy from the coal, and then comes the petroleum and natural gas, which is about maybe like 20% of it. And then we have a hydro, and then nuclear and wind and nuclear energy sources are very low in comparison to the coal and hydro. And uh, and also uh, they also burning up coal and petroleum also causes some environmental pollution in it, like air pollution caused by burning up coals or petroleum products. This caused by the air pollution causes it. And how the oxide of the carbon, nitrogen, and sulfur that releases on burning the fossil fuels are acidic oxides and leads to the acid rain. So burning of these fossil fuels, particularly here we're talking about the coal and petroleum gas, produces oxides of carbon means carbon dioxide, and nitrogen oxide and sulfur oxide, which causes the air pollution. Also, the pollution caused by burning of fossil fuels can be somewhat reduced by increasing the efficiency of the combustion process, and using variant technology to reduce the escape harmful gases. So it can be reduced by somewhat reduced. One is like combustion, like when it burns, when fires happens, when there is a fuel, then there is a heat, and there is a oxygen. When the three things will combine, it will burn, there will be flame, there is a combustion here. And if the oxygen is not enough, that it will burn it will burn, but it will not be efficient. That means all the power of the fuel cannot be converted into heat. So most of them will escape into air without converting into heat. And these are mostly like oxides of carbon, nitrogen, and sulfur. And if you provide enough oxygen, the combustion will be most efficient, and this way we can reduce the harmful. And also there can be techniques by which the harmful oxides can be catch up and from getting released into atmosphere. And thermal plant, thermal power plant. How it work? Like thermal power plant work on the basis that we first burn the fossil fuels and to heat up the water, and water heats up and to produce steam, which further runs a turbine to generate electricity. So what we are doing here, like we are like heat, this is water here, and we are heating the water, so it creates a steam, and then this steam is used to rotate the turbine, the blade of this turbine, and after rotation the generator will, the mechanical energy that we have studied in earlier classes, the generator, which is a DC generator, will convert this mechanical energy into the electric energy. Electric energy will be there. So this is how the thermal power plant works. They only works on the steam of heat, and to run the turbine, the blades of the turbine. Hydropower is like produced from the water. Hydropower plant converts the potential energy of the falling water into electric energy. This is how the hydropower works, and this is a dam, a reservoir, and when this flow and with high pressure water is used to the same thing to rotate the blades of this turbine, and the generator generates the mechanical energy, converts the mechanical energy into electric energy. And like improvement in technology for using conventional source, like as we know that these fossil fuels and the non there are some sources like coals, petroleum, they are limited, and so these resources will be exhausted if we extensively use them. So we have to convert and slowly transition towards the clean energy sources, where there is no source which has a limited quantity, like petroleum and fossil fuels are limited. If all of these are extracted from the earth surface, there it will end soon. Like we have a one more way of extracting clean energy. It's from the biomass. And what is it actually? These fuels are the plant and animal produce, and so these are the plant and animal produce, and source of these fuels is has to be a biomass, because bio means life, mass means mass, and mass means you can say produce. However, do not produce much heat on burning, and lot of smoke is given out of this. And biomass comes, the gobar gas is the one of the best example of the biomass. What we are doing in it, and along other than gobar gas, we are also burns charcoal without a flame, and it comparatively smokeless and has a higher heat generation efficiency. So let's talk about this biogas plant, where we are storing some cow dung here, then it's goes some in an aerobic decomposition, and then methanes and flammable gases are produced. So what we are doing here, the digester is a sealed chamber in which there is no oxygen. So we put here the animal cow dung, this thing, and this is called digester, and it is a sealed pack, so there is no oxygen, so oxygen cannot enter here. What happens in the oxygen, there are some bacteria which do work on we break down the complex molecules into simpler one in absence of oxygen, so they don't require oxygen. So they are called anaerobic bacteria, and they do not require oxygen to decompose or break down the complex compound on a cow dung slurry, and the decomposition process to be completed and complete to be complete and it generates gas like methane, carbon dioxide, hydrogen, and hydrogen sulfide. So these are the gases which are being produced by the these decomposers. And so methane is acts as a fuel. Biogas is an excellent fuel and contains methanes. So methane is a fuel. When methane burns uh, in heat, it is a very flammable. It is a kernel of methane is a CS4. This is how in most of villages this way of clean energy can be obtained for domestic purposes only. Let's talk about the wind energy. And we get again the help of wind to rotate these blades, and generators converts mechanical energy into energy. To generate electricity, a rotatory motion of the windmill is used to turn the turbine of the electric generator. So same thing is happening. What we are doing, even in case of water, we are steam heating up, and the steam is used to rotate the blades of turbine. Here also we in wind energy we are doing the same thing. And Denmark, which is a European country, is called country of winds. More than 25% of their electricity needs are generated through the vast network of the windmills. So a lot of windmills are there in Denmark. So let's talk about some alternative and non-conventional source of energy. This is solar energy. So how do we use the solar energy? Like sun is being radiated. Sun has been radiating enormous amount of energy at present at nearby at a rate of nearly 5 billion year. So from 5 billion year when the sun was formed, it has been continuously radiating enormous amount of energy, and Earth has an age of about 4.5 billion year billions of age, and with the continued radiating at the rate about 5 billion more year, that means it will still continue to radiate and a lot of energies in also next 5 billion also. So we can just say that sun age will be like about 10 billion years, in which 5 billion has already been lived, and only the small part of the solar energy reaches the outer layer of the earth atmosphere, outer layer only, and only half of it is absorbed by our atmosphere while passing through the atmosphere, and rest reaches the earth's surface. That means only half. When the solar small parts of solar energy reaches the outer layer of the earth atmosphere, only small part, and half of it is absorbed by the atmosphere only, and only rest of us, like maybe I don't know the exact percentage, but after lot of consumption of energy by atmosphere and lot of energy get deflected out from the atmosphere, nearly only few percent of the sun's energy reaches on earth's surface. And we know the position of India in a very good way, like it has almost in the equatorial region where the sun rays sun rays falls directly and more intensely. India is lucky to receive a solar energy for a greater part of the year. It is estimated that during the year, India received the energy equivalent to the more than the 5,000 trillion kilowatt under clear cloudless sky. The daily average is like 4 to 7 kilowatt per meter square. Solar energy reaching unit area to the outer edge of the atmosphere, but exposed perpendicularly to the rays of the sun at the average distance between the sun and the earth is known as the solar constant. It is estimated approximately 1.5 kilojoule per second per square meter to this. So this talks about how much energy we are receiving from the sun and in per square meter. And here we are, the solar energy can used to cook the food. Here it diverts the sun rays and concentrate it. A typical cell develops a voltage of, this talks about now solar cells, like which converts solar plates. These plates converts electric energy, solar energy into electric energy. A typical cell when exposed to sun, a typical cell develops a voltage of 0.5 to 1 volt and can produce 0.7 watt of electricity when exposed to the sun. Large amount of solar cells are combined in an arrangement. These are called solar cells panels, and that can deliver enough electricity for practical use. So one solar cells can produce a voltage of about a 0.5 to half to 1 voltage, and multiple combination of these solar cells can produce enough voltage to run the electricity in our homes and can be used for practical purposes. Silicon, which is used for making the solar cell, is abundant in nature, but availability of the special grade silicon for making solar cells is limited. So silicon is an important metal. Actually, this is a metalloid semiconductor, which has a broad property of matter and non-matter. Is used for make solar cells. We do also obtain energy from sea in the form of tidal energy, and due to the gravitational pull mainly of the moon, on the spinning earth, the level of water in the sea rises and falls. So this happens due to the moon's gravity. Or when the earth spins, the water level rises and falls, and we can utilize this energy. When the water rises and water falls, this rising and falling of the water level can be used to extract energy. This phenomenon is called high and low tides, and the difference in the sea gives us the tidal energy. Tidal energy is harnessed by constructing a dam across the narrow opening of the sea to the sea. The turbine fixed at the opening of the dam converts the tidal energy into electricity. Let's talk about the wave energy. Similarly, at we are like using water to create electricity, like rising of water and falling. The similarly waves can be used. Water waves can be used. Similarly, kinetic energy produced by the huge water waves near the sea can be trapped in a similar manner to generate energy. Like there is one more thing, ocean thermal energy. What is that? So there should be like a temperature difference between the surface of the water and 2 kilometer beneath this. How it works? Let me study this. The water at the surface of the sea or ocean is heated by the sun, while the water deeper section is relatively cold. So the when heat sun will heat up this water, and this upper portion of the water will be warm up, and deep inside beneath the ocean will be the relatively cold water. And this difference of the temperature is exploited to obtain energy in ocean thermal energy conversion plant. And these plants can operate if the temperature difference between the water at the surface and the water at the depth of the 2 kilometer is more than 20 degrees Celsius. So this thermal this ocean thermal energy can be utilized when there is a difference between these upper and lower water temperature is minimum of 20 degrees Celsius. If it is more than 20 degrees Celsius, if the difference of the temperature here and here is more than 20, then it can be utilized. And how it can be? The warm surface of the water is used to boil a volatile liquid like ammonia. So volatile liquids like ammonia can be used to boil, and the vapor of the liquid is taken to run up the turbine again. The vapor and steam will be used to rotate the turbine, and DC direct current will be generated. And the cold water from the depth of ocean is pumped up. It will be pumped up to condense the vapor again to liquid. And this 20 degrees Celsius below temperature is used to again cool down means this was the steam was used to rotate the blade. Again the steam, which is a gaseous form of the ammonia, is converted into liquid ammonia by passing through this low comparatively 20 degrees Celsius low 20 degree less saturated water. So what's geothermal energy is? Like when the molten rocks formed in the deep hot regions of the earth crust are pushed up towards upwards and trapped in a certain regions is called hotspots. And where the hotspot opens, it produces lot of heat, and then heat is can be utilized. And these steam trapped in the rocks is routed through the pipe to the turbine to use the to generate electricity. We have another form of energy which is a nuclear energy. We have two types of it. One is a nuclear fission and one is nuclear fusion. In nuclear fission, what we are doing, a nucleus of the heavy atom is used like uranium, potassium, and thorium. And when bombarded with the low energy neutrons, it splits into lighter nuclei. So heavy atoms is bifurcating or trifurcating into the uh, lighter uh, nuclei, means lower atomic number elements. So during this, a lot of energy is used, and this energy is again utilized. Lot of heat and energy used. This energy again utilized to heat the water. When water will heat it, again steel will form, and this steam will again used to rotate the blades of turbine, and mechanical energy gets converted will be can be converts into electric energy by the generator. The fission of an atom of a uranium, for example, produces 100 million times energy produced by the combustion of an atom of a carbon from the coal. So this creates a lot of energy. It is producing 10 million times more energy produced by the combustion of atom of a carbon from a coal. So here we're just comparing one atom of uranium and one atom of a carbon from a coal. And when we compare even the uranium atom, one uranium atom is breaking down, and some lighter elements is forming along with the heat. And this energy is 10 million times more than the energy that we receive from a carbon atom while combustion. And how this energy come from, like say how this nuclear energy, how we get nuclear energy, like we get through this formula equal to mc square. In nuclear fission, the difference of the mass between the original nucleus and the product of the nuclei converts into E. So what is happening when the higher nuclei is like bifurcating into lighter nuclei? There its mass becomes still greater. So this extra mass converts into electricity with this formula equal to mc square. This extra mass converts into energy, not electricity, sorry. It converts into energy. So this is how the mass and energy is converting. In nuclear science, energy is often expressed in units of the electron volt. And 1 electron volt is 1.6 into 10 to the power minus 19 joule. It is easy to check from the above equation that one atomic mass unit is equivalent to about 931 mega electrons. Opposite things happens in nuclear fission. When two lighter nuclei is bombarded, is being together and fused to create a one heavier nuclei, and here it's nuclei to two small, these atoms will be more than the newly heavy created nuclei. Then the extra energy, the extra mass, where does the extra mass will convert into energy with this equal to mc square formula. So fusion means joining a lighter nuclei to make a heavier nucleus. And hydrogen most commonly hydrogen or hydrogen isotope is used to create a helium, and it releases tremendous amount of energy. As mass of the product is little less than the sum of the masses of the original individual nucleus. So these original individual nuclei has more mass than this product formed nuclei. So the extra mass converts into electricity energy, and this energy is again utilized to boil the water and steam. It will steam, and again this steam is used. High pressure steam will be used to rotate the turbine blade. This condition, the condition needed for the process is extreme, million degrees degree of temperature and millions of pascal pressure. So this equation happens in a very extreme condition. One, it needs a million degree Celsius, a million degree temperature. Also, it also needs a million degree pascals of pressure. So this is very high pressure and high energy is required to fuse the two lighter atoms to form a heavier one. So there are some, along with the using the when we are using some form of energy, there will be environmental consequences also, and pollution, and a lot of things will be there, which will pollution will be also there, and we have to replace our energy sources from conventional to clean energy, those which are renewable forms of energy. But still in India we uses around 50% of our energy from the coal. So let's do a quick revision. Our energy required, our energy requirement increases with our living standards of life. Those living in a higher income classes or high income countries, they use more energy, and those who are in a poor country, they per capita energy consumption is comparatively low. In order to fulfill our energy requirement, we try to improve the efficiency of energy usage and also try to exploit the new resources. We also exploit the new resources of energy, and we also need to look new resources of energy because of the conventional sources of energy like fossil fuels are in danger and getting exhausted soon. So they are getting exhausted, and they, you know, they are once they are used 100% like utilized, or like taken up from the earth's surface, we cannot use them. That is why we have to make a transition from the conventional sources to the clean energy, like from wind, from water, from tidal energy, and from the nuclear energy. Energy sources were the energy source we select would depends on the factors like it should be cost, ease and cost extracting energy from the source. It should be, you know, very cost. It should not be very costly and efficient to a technology available. It should be efficient efficiency of the technology available for using that resource of energy, and environmental impact for using the source. We have to see like how costly it is and how efficient technology has been developed to extract that energy, and also that there should be a no and minimum environmental impact on this. And based on these criteria, we select our energy sources. And many of sources unlimitedly driven their energy from the suns. So let's quickly do it. That the solar water heater cannot be used to get hot water on. It cannot be used on a cloudy day because there will be no sun rays. Solar water heater, what is that? It's like it has some concave shaped uh, like shaped formation, and when sun rays hits this concave surface, it reflects and concentrate and get focused on this here. And where if you put anything here, it will definitely get hot. And which of the following is not example of the gobar biomass energy? Biomass is energy like which is used for the like living plants and animals which are dead now, and they are from the living things, living either plant or animals. And nuclear energy is another type of energy which is not here. Coal and gobar gas and wood are the this. Here we are doing combining the atoms here. It is no role of our bio here. Human bio here means living. And most of the source of energy was represent we use represent stored solar energy. Which of the following is not ultimately driven from the sun energy? So these are biomasses. These are ultimately driven from the sun's energy, and nuclear energy is the only one which is not, which is driven by only the like from the atoms, from the molecules. When we are either splitting or fusing the two elements, the difference of the mass is converted into energy. So here ends this chapter.